Welcome to the first Nutrient in a Circular Economy Summit for 2022. Before I begin, I would like to acknowledge the Gadigal people of the Euro Nation upon whose ancestors' land this UTS stands, and I would like to pay respect to the elders both past and present, acknowledging them as the traditional custodians of the knowledge of this land. So my name is Shera Punto, and I'm a senior lecturer at the School of Civil and Environmental Engineering at UTS, and I'm also one of the CIs. So I'm moderating this session, and in the second session, Dr. Leonard Tejing will be moderating that. First of all, I just want to thank all the lead CIs for sending your bio and the abstract within the short notice. And actually, as we will be having this summit in a more formal and a more organized way in the future, so we thought that this way it's better to start in a bit in a more formal way, and that in the future we can potentially expand this summit to a larger audience, and then so that we can reach our the activities of the summit to the wider audience. So we are supposed to have 8 speakers today, but Dr. Liu Yi from Queensland University of Queensland had to withdraw at the last minute because of some medical emergency with her son. So we'll have 8 speakers today, so we have some time for a time buffer. Just a housekeeping, so we have each speaker is allowed 15 minutes, allocated 15 minutes for their presentation. Then would ideally, if you can present for 10 minutes and then keep aside 5 minutes for question and answer session. So after 10 minutes, I'll give you just a reminder, and then we can wrap up for more question and answer session. But of course, we have, as I said, some buffer time. After the first speaker, after Sean's presentation, we will have some photo session. Maybe if everyone can later on put on your camera, and then we can just want to screenshot and then as a record for our the first summit. Without further ado, I would like to welcome now Professor Sean, who is the Erc Hub Director, and so that he will update the progress and also welcome all the participants. I thank you very much, and please enjoy the session today. Thank you. Sean?
Yeah. Try to share my screen. Can you see my screen?
Yeah, that's fine.
That's great. So I'd like to begin acknowledging the traditional owners of the land on which I stand and pay my respect to elders, past, present, and emerging. Hello, everybody. My name is Ho Kyung-seon, the director of the Nutrient in a Circular Economy. This is our privilege to organize the first Nutrient in a Circular Economy Summit, which called first NiCE Summit. First of all, I'd like to thank you, the organizer, Dr. Shera Punto, and then Leonard Tejing, also Ibrahim S. Salebi, and then Stefano Friguela. So they have been involved this organization for the NiCE Hub for the last 6 months. So we have a weekly meeting to reach this level. So very happy to share for the good news of our ARC Hub. So we are very much ready to start. So that I want to update what's the progress of the ARC Hub, and then what will happen for the next couple of months and years. Also, today's meeting is the most important. It's what we want to we want to get to know each other, because even though we are working together in ARC NiCE Hub, but I'm sure that not many people know each other. Also, they don't know who is doing what kind of research, how we can collaborate. So making sure this first summit is about to discuss about research, not too many administrative related questions. If you need any administrative, for example, like a tax invoice or some of the Annex C, so you can just send the email. We are happy to follow up. Also, we will keep you updated how you can progress the administrative of this project. But this time, this next 3 hours, we will focus on who is doing the what kind of research and how we can collaborate in the future and how we can work together. So if you can focus on this kind of research item, that would be very much appreciated. So this is the outline of the today the summit, the progress of the AIC Hub. So who are our final partner organizations? And then I will brief what kind of the research we are planning to do as a linear and circular economy, also contribution to the sustainable development goal. So what research activities we are planning to do in this program? So what's the next step we have to follow? In 2019, so I met Stefano from the University of Melbourne. We attended a conference and then we discussed about the AIC NiCE Hub, how we can create this kind of opportunity. And then 2020, so we had a weekly, almost a monthly meeting to organize some of the industry partners. And then we push very hard to make this kind of happen. And then we submitted our AIC Hub application November 2020, although as you know, we had a very serious pandemic, but yeah, luckily we got a strong support from the industry partners. And then we submitted our application November 2020, and we got a very good outcome, July 2021, last year. And since then, so we have had a lot of follow-up. Initially, because of this pandemic, the international partner organization withdrew because of the uncertainty of the international collaboration. So we lost 3 international industry partners. So we tried to look at some of the alternative local industry partners. And then luckily, yeah, we tried to satisfy our threshold of the cash contribution from the industry partners. And what happened is that only this year, so we got another problem because of the inflation as well as some of the economic recession. So small businesses, they all withdraw this project because of the not healthy cash flow. Also, we had a problem of the construction company. So we used to have several construction industry partners. And then because of this pandemic, they had a little bit of problem for the construction economic situation. That's one reason. So we lost 3 construction company. But luckily, we got a lot of strong support from the water utility as well as some the water technology company. So we are very happy to satisfy all the cash contribution from our minimum threshold, and then ready to go our project. So we have generated a website, also social media, also some industry partner. We have changed a lot, and I will introduce who are the new industry partners and then new universities. Also hub agreement completed, and then project agreement is still going on. So after this meeting, so we can finalize our project agreement, which is the Annex C. So you can complete this one and then we can start your activity. So officially, we will start our hub on 31st of July this month. So just a few weeks later, we will start officially our project. Also, official launch will be held on 17 November 2022. So we have World Toilet Day, 19th of November. That's the reason why we set this day, 17th of November, as the official launch of the project. So we are planning to invite the Minister of Education, who is the Jason Clare, also the AIC CEO, Judy, and then Executive Director of the AIC, also UTS, DVCR, Vice Chancellor, and Dean, and then our head of school. So if you want to invite any important people from industry partners, so please let us know. We are just at the planning stage for this official launch. This will take only 1 hour, so we will have official launch. At the same time, we are planning to organize the second AIC NiCE Hub Summit. So in the morning, we can have just one session, and then we will have official lunch for 1 hour, and then we can have a lunch together with all the people. And the afternoon session, we will also invite some of the industry partner, also CI, to make them their own research progress and then presentation. So we will organize second AIC Hub Summit in 17 November 2022. So if you have any suggestion for this official launch, so please let us know. We can make a very memorable launch of our AIC Hub. So this is the logo we have for this AIC Hub from the Aboriginal artist. So this is our logo, so you can just utilize it for your website. Also, when you have some communication of the AIC NiCE Hub, so you can utilize this logo. Also, several PhD students we have in this summit. Also, we are working with the project together with them. So now is the time you can recruit your own PhD student or research assistant, research associate. So we can progress our project for next 4 years. Also publishing some journal article. So whenever you publish some paper, yes, just let us know so we can promote in our communication channels using social media and website. Also, we are now recruiting the scientific and industry advisory committee members. So if you have anybody who would be very suitable, so please let us know. We will finalize all this governance committee members. Also, Hub Manager Leonard, Teaching, and Ibrahim, they are helping this Hub coordinator role. But next couple of weeks, so we will have official Hub Manager who will take care of general administrative and then business as well as some commercialization opportunities. So if you know any suitable Hub Manager, so we are ready to promote this position through the job seeker. So please let them apply, and then we will select the Hub Manager next couple of weeks. So this is our partner organization. So we have 7 universities: UTS, University of Melbourne, and Griffith University, Western Sydney University, and Southern Queensland University, University of Southern Queensland, and Victoria University, and the University of Queensland. Also, we have 23 partner organizations. So some of them are existing ones, and then some of them are new partner organization. Urban Utilities, City of Sydney, Siontech, Southeast Water, Office of the Chief Scientist Engineer, Pyrocal, Origin Water, Melbourne Water, EIC Activities, ISOM, AJJ Technology, Durax Group, and Parkway Process Solution, Queensland Water Directorate, and City of the Logan, and Icon Water, the Royal Botanic Garden Sydney, Nutritech Solution, Hess Land and Water, Hydrogen 2.0, South Bank Parklands, and Department of the Environmental and Science, Queensland Health. So they are all very much strongly supportive for this project to make this happen. Also, we have 3 international organizations, EWAG from Switzerland, UNIST with the National Institute of Science Technology in Korea, and the Rich Earth Institute in the US. So they are also supporting our technical as well as the industrial oriented commercial opportunities. So please feel free to contact them because they are our team members. So we will continue to work with them for next couple of years. So attracting the industry partner is very difficult, but maintaining to satisfying and working together with these industry partners are much more difficult. So we need a very much active role from each university CI to engage with the industry partner, to work with them and to make sure that how they satisfy our project progress and their benefit. So please let us know if you need any support. We have a hub manager as well as some kind of funding to support their demand. So we will keep discussing to help each other for this industry partners. So this is our general concept of the AIC NiCE Hub. So we live in the linear circular economy system. So we have nitrogen fixation using the Haber-Bosch process. So this is the very energy intensive. So you need 100 bar pressure and then 1000 your high temperature. So world energy consumption require almost 2% of this kind of production of the fertilizer. Also, phosphorus is limited reserve. So we need to find the alternative for the future. So we look at this nitrogen and phosphorus and produce the food, and then we consume this food and produce the CO2 N2, which is the greenhouse gas emission material. And then also we produce the nitrogen phosphorus in the environment, and we have to also reduce our nitrogen phosphorus. So if we make sure this kind of circular linear economy to circular economy system, so we can make a lot of benefit in terms of the economy as well as environment. So we try to achieve this nitrogen phosphorus, how to make fertilizer, produce the food, and then we can consume. So this is the way we want to propose our AIC hub for the overall circular economy system in terms of nutrient. If we achieve this one, we can contribute to significantly sustainable development goal. So you can see the sustainable cities and communities. And number 13, climate actions. We can contribute also life below water. Because of the nitrogen, phosphorus, algae will grow, and then the ecosystem of the water below will have a damaged, so that we can protect our environment. Also, responsible consumption and production can be achieved, and the clean water, sanitation, good health and well-being can be achieved from our circular economy in nutrient. Also, zero hunger can be contributed for our concept. So that's what we are trying to achieve for the SDG from the United Nations proposed. So this is the AIC NiCE Hub, how we can achieve these goals. So you can see the household wastewater. We produce the urine and a lot of black wastewater, gray wastewater. And this one is the industry wastewater, a lot of nutrient-rich wastewater. Also livestock wastewater, so pig and cow they produce a lot of nitrogen, phosphorus, wastewater. So we treat this kind of nitrogen, phosphorus, and we can also produce some of the nutrient from our wastewater. So NiCE Hub can contribute to convert our wastewater nutrient to fertilizer system. Also, after wastewater treatment plant, so we have food waste as well as the sludge. So anaerobic digester can produce a lot of biogas as well as some of the biosolid, biochar, and the composting. So supernatant also contain very high concentration of nitrogen and phosphorus. So we can convert this kind of nutrient source from household, industrial, livestock, as well as anaerobic digester. So we can convert this nutrient as a fertilizer to grow some eatable crops, also non-eatable crops. So we can make some green wall or tough glass, as well as the city parks. So we can contribute our fertilizer, also make sure that our clean environment. So that's the overall, our objective of the AIC NiCE Hub, to extract nutrient as much as possible from different water sources. And this is what we can achieve from the specific our nutrient recovery system. So urine, we're targeting on urine because the urine has a very high concentration of nutrient. Also relatively easy to collect compared to the industrial wastewater or livestock wastewater. So we can utilize this urine as one of template from this nutrient recovery system. So how to effectively collect urine, how to effectively we can processing to convert urine to fertilizer, how to optimize this fertilizer, and how to apply this fertilizer system. So that's what we try to achieve from our 7 university CIs, and then 23 industry partners, and then 3 international collaborators. So they have their own expertise to make sure that our own expertise, as well as the economics, how we can make sure this economic with the stakeholders. Also engagement, learning, and communications are our objectives. So stakeholder engagement are very important. So we will make sure social technical issue from the different universities. So this is the University of Technology Sydney have developed this membrane bioreactor system to convert our urine to fertilizer. So our university has a 15-story, and then we have a urine separation toilet, and then we collect the urine at the basement, and then we have produced every day around 2,000 liters of the urine, and then we process the biological treatment process to remove the smell and then some of the ammonia to convert to nitrate. And then we distillate and produce the very concentrated urine fertilizer, which called over. So you are valuable, urine is valuable. So we tested some of the hydroponic system together with the Royal Botanic Garden. And then we found out very similar performance of the commercially available fertilizer. So that's our current technology we have developed. So we are collaborating with the Royal Botanic Garden EIC activities. So they are trying to collect some of the precipitant, strobite, and calcium phosphate to make a bioblick for the construction application. Drex Group, they are the fertilizer company to try to make a more optimized fertilizer solution. Origin Water, the membrane technology, also Office of the Chief Scientist, Engineer. In general, they are supporting the circular economy in New South Wales. City of Sydney, they are happy to purchase our fertilizer to apply to their parkland. Also, Siontech, there are some of the membrane technology we are trying to collaborate. Also, Southeast Water, they are very much interested in the downstream of the wastewater treatment impact. So we collect the urine at the upstream. So we have a reduced carbon, nitrogen, phosphorus concentration in a wastewater treatment plant. So Southeast Water, they are very much interested in how this will impact overall saving of the nitrification process in a wastewater treatment plant, as well as the environmental discharge of their effluent for the nitrogen and phosphorus, and then how this will impact also overall CO2 and N2, greenhouse gas emission. So we are collaborating with Southeast Water, and they are also interested in the technology overall. So even though the Sydney node, we are targeting on the biological treatment process, so Brisbane node, so Urban Utility and Stefano, there we are very much focused on the electrochemical process. So the Southeast Water, they also want to develop very simple and low cost fertilizer production technology. So that's we are collaborating with the Southeast Water, Rich Earth Institute and UNIST, IWAC, Western Sydney University. We are also providing this fertilizer to look at the soil behavior, also fertilizer performance, also hydrogen 2.0. So from our urine, so we produce a lot of ammonia. Ammonia can make a hydrogen source. So how we can combine this ammonia to hydrogen production? So we have a collaboration with the hydrogen 2.0. So that's what we are planning to collaborate for next couple of years to look at the overall technology side and the production, as well as the fertilizer application. Also, ISF people, Dana and Jason, will talk about the socio-technical issue for their presentation in the second session. So I will not discuss about the ISF people economics as well as the engagement issue in this program, but they will work together with the Sydney node to develop the overall holistic approach of this technology. So that's what we are planning to do in Sydney node. And what's the next step? So still some of the industry partner as well as your university CI needed to complete the project agreement, Annex C. So based on the today's summit, I'm sure that you will have a better direction, better idea how you can design your Annex C together with your industry partner, how you can allocate budget. So you can have a finalization of your Annex C. Also start project 31st. So PhD student, research associate, also very important to deliver our project. So please recruit your PhD student, also research associate to progress your project faster. Also regular meetings with your industry partners, and the launch of the ARC Hub, 17th of November, Thursday. So please, if you have any suggestions, so please let us know. Also, we will keep following up your progress. So this is the KPI. So every year we will request some of the basic information from your organization. So how much budget you spend, also number of the mentoring program, number of postdoc, PhD student in your partner organization, also number of the HDR student, how they are collaborating together with the industry partners, also joint publication, also visit to some of the investment of the hub, also government, industry, business community briefings, also number of talks given by the hub investment, which are open to the public, also research output, also you can have a nature of the commercialization commentary about this hub investment achievement and additional funding. So this project is just our seeding fund. So you will have an opportunity to engage some more industry partner and you can have a further funding for your scale up your research as well as the research translation opportunities. I'd like to thank you again for the university CIs. So their strong support for making happen this project. Also industry partners, and then AIC Hub. So they are the 7 universities we will work together for next 4 years. So please feel free to contact. Also, they have their own industry partner. So you can also engage with them and then make this project very successful. Thank you for your attention.
Thank you, Sean. Thank you very much. So I think we are out of time now. Probably we can leave for question answer in the discussion time.
Yep, that's fine.
Okay, Sean.
Thanks.
So we have, I want to invite next speaker, Dr. Stefano Frigue from the University of Melbourne. Please, Stefano, yes.
Thank you, Sharon. I will share my presentation. Okay. Can you see it?
Yeah, this is in present your.
Can you change your display settings, Stefano, to make it a full view?
I just did.
I think you are showing this other screen. This is your presenter's mode.
Good thing we got 5 minutes extra. Okay, try again. Any better?
It's the same.
It's still the same.
Yeah, it shows that your presentation, the presenter's view, not the other full screen view.
Maybe can you try to go to the top to the display settings? Try to just put the drop down upper left.
Our left side. Display settings.
On the computer?
Yes.
Usually it works this way.
And do you have 2 screens? Or?
Yeah, I got 2 screens on.
So I think you have to.
Maybe I just remove one screen.
Yeah, you have to share the right screen, otherwise it goes to the other screen.
Oh, I didn't share the screen, I shared the presentation. Maybe I can try to share the screen.
Yeah, you share the screen, yeah.
Okay, let's see. This way.
Still the same.
Okay, so I'll just unplug.
We could see it clearly enough. Stefano. I think it was okay then.
Yeah, that's
fine.
Yeah.
That's good.
Does it work?
Yes.
Yep.
Okay. Yes. I haven't switched it on for too long. Okay, so nice to see you, everyone. Most of the people here already know me. For those who don't know me, or for those who have forgotten, Stefano Freguia. I'm at Department of Chemical Engineering at the University of Melbourne, where I've been for the last 2 years. Before that, I was at UQ for about 10 years. So here, do you actually see Kara in the corner, or is it just me?
Just
yeah, so that image in the bottom right corner is Fisherman's Bend campus at Melbourne. So this would be Melbourne University's new campus to be delivered approximately in 5 or 6 years' time. So this will be the target of a potential future trial of urine diversion with the technologies that we are currently developing through NiCE. We would have liked to have that as part of NiCE, but the timing is not perfect. But certainly there will be follow-ups beyond NiCE, and this would be a target site for implementation of a larger scale trial, perhaps. So I will be talking about the University of Melbourne projects within NiCE, what we're planning to do. Before that, I'd like to move back to an introductory note. Oh, there you go. So this image was already shown, by Sean. And this was really keeping us very busy a couple of years ago while we were planning the planning phase for the hub. So when I met Sean for the first time at the conference dinner in December 2019, we started discussing about our respective research. The focus quickly shifted towards urine, which was really high in our rank of topics of interest. And we started to talk about our technologies and what needs to be done to improve it. And then soon enough, we realized that we were really almost entirely focused on this bit, so urine processing. And as engineers, that's what we do. But we came to the realization that if we are going to implement this concept of harvesting nutrients from urine, technology is not going to be the limiting step. Although there's still a lot of questions to be answered, a lot of development to be made, we realize that we can't achieve implementation unless we address all these other aspects. And so we mapped it out and realized that urine collection, as well as making optimized and commercializable fertilizers, and fertilizers that are usable and effective on target plants and crops. So without these elements, we will not be able to implement it. And this is where we started to map out the work of NiCE, together with this outer ring, which includes the very important whole of systems economics. This is something that the industry partners asked us from the very start. How much is it going to cost? Is it going to make economic sense? And particularly for this topic, acquiring not only regulatory approvals, which are essential, but also the social license is highly important. And so we realized our expertise is not enough. We should not go for another linkage project. So what we should do is to try and put together something bigger. And this is where the idea of the hub was created. Obviously, urine is a big part of this hub, but this is not the only place we're going to look for nutrients. However, the work that will be doing out of Melbourne is mostly focused on urine as a source of nutrients. So I'll give you a little bit of background. So the technology that we'll be further developing and mainstreaming perhaps as part of NiCE out of Melbourne is coming out of a previous ERC linkage project between urban utilities and UQ, which was my previous working place. And so out of that linkage, we developed a small-scale trial at luggage point treatment plant, where we had a dedicated toilet block with waterless urinals and a set of reactors that we tested and optimized over the duration of the project. So this was successful and attracted media attention. Urban Utilities was very happy, and they were interested in continuing, but also they were concerned that another technology-oriented project was not what we needed. This is what they also wanted, something bigger that that includes not only technology, but also social, economic, and agri aspects. And so they quickly agreed onto the idea of supporting the hub. So now, what is this technology that we have developed through this project, and why are we pursuing further development through the hub? So here we go. Got stuck. Okay, here we go. So microbial electroconcentration, which was affectionately named UGOLD, similar to Sean's technology URVAL, which identifies the value in urine. We identified the fact that urine is so valuable that can be considered gold. So we won't really deep dive too much, but a little bit to give you background of what the technology is about. You can see here what's inside one of those cells that you've seen in the picture in the previous slide. So this is an electrochemical cell with an anode on the left and a cathode on the right. So this is like the same effectively as a battery or a fuel cell. It's really a fuel cell rather than a battery, where we feed urine as a fuel, and we use oxygen to liberate the energy of that fuel. So urine is a fuel because it contains a lot of organic matter, 10 grams per liter of organic matter, which is most of which is readily biodegradable. When we collect fresh urine, there's most of the nitrogen is in the form of urea, and the organic matter is complex. After a period of time, which if you just let it happen naturally, might take up to a month, but really after you do it in a technologically advanced system, it might take only a few hours or less. The process of hydrolysis leads to quite a few transformations. They happen best in the presence of oxygen, particularly urea hydrolysis to ammonia. And with that, the pH goes up to 9, and a lot of the calcium and magnesium salts, including struvite, precipitate out. And we can just already harvest those immediately. That's quite a bit of the phosphorus already, by the way. But then the nitrogen is really staying in the liquid phase. So this technology is really targeting the nitrogen primarily. So through the movement of electrons through a circuit, these electrons are generated from the oxidation of chemicals in the urine. We are moving ions as well. So we have a cation exchange membrane and an anion exchange membrane. And similarly to what happens in electrodialysis, we're moving positive ions into a compartment in between the two electrodes, and negative ions as well, moving that way from the cathode side to that middle compartment. So this way, we're able to harvest ionic species, and actually the nutrients that we're targeting are all small ionic species and are selected for in this system. So the beauty of this is that it requires no chemicals, no process controls, as it's self-controlled, and in an ideal world, no power. We did demonstrate it with no power in the lab, but at very low rate. So, yeah.
Stephen, you have 5 minutes more. Remaining 5 minutes, yeah.
Okay, so let's wrap up the next slide. So this is really good for a decentralized process because you don't want to have a lot of controls and maintenance issues. But however, we moved away from the no power because it was working too slow. We added a bit of power, making a bit of hydrogen at the cathode. That hydrogen can actually be recovered and used to supplement some of the energy requirements, so improving the energy efficiency there. And the rates then go up quite a bit so that the system is nice and compact. What we achieved from that trial is that the urine was concentrated by a factor of, so the volume was reduced by a factor of 10. Concentration of key nutrients was increased by a factor of 3 to 5. We have recovered up to 65% of nitrogen. There was no problems with the pathogens because of the biocidal conditions that are created in that mid compartment with a lot of ammonia. Good rate at power consumption, which might not mean much to you, but what is important is that this is less than the combination of the energy needed to denitrify, remove nitrogen in the treatment plant, and the Haber-Bosch energy required to make ammonia in the first place. So we're better off than where we are at the moment. So that's the key. The product that we made is liquid, which contained all the key nutrients at the concentration which are still a bit low for liquid fertilizer markets, but they are in line with the low end of what you can find in the liquid fertilizer market, also including organic matter and a lot of trace elements. So we cheered to that and also did some home-based trials because we're running out of time. We're not going to talk too much about micropollutants, but this is also another key question. What happens to the antibiotics and all the other stuff that goes through our urine? The beauty here is that because of those membranes only allow small ions through, we removed 99% of what we found for most of the micropollutants that we were able to find in there. Only a few of them broke through, and those are not the ones of main concern, although this was just the result out of one trial, and this will need to be further investigated. I'll skip on this one, otherwise I won't have time on my main slide. But basically, this is just to say that we have a market for liquid fertilizers. It's worth quite a bit. So about $500 million, which is actually 1/3 of the total fertilizer market in Australia. That's because not in terms of mass, but in terms of value, liquid fertilizers are more highly priced. And they also have a lot of advantages compared to solid fertilizers. With the advent of urban farming and the need of liquid fertilizers in urban parks and gardens and lawns, I think what we should aim for is to make the circular economy at city scale so that we are actually harvesting nutrients where the nutrients are consumed and released. So the cities are the places where we have a lot of urine, and the cities are the place where we can implement urban farming, minimizing the movement of liquid along large distances. So what we're going to do at Melbourne University as part of this hub, there's quite a few activities. So the main activity is this Center 1, Project UM1, which will be undertaken by a postdoc. which is field testing and mainstreaming new gold, delivering a 300 liters a day pilot at the Brisbane location. This will be an outdoors location. We still cannot disclose it, but will be a location of primary visibility. So that's basically taking what we had, improving it, and just putting it to the test of the real world in a public toilet. Then we don't have all the answers to technological improvements, but we will be. Are we out of time? It's just a couple of minutes. Improving rates, reducing power consumption, and increasing nutrient recovery. Because one of our partners is interested in sludge digestion side stream, we'll also target that for some of the trials to see how much nutrients we can harvest in a centralized system. 3 PhD projects. One already has a name on it. Negar is actually in the meeting, looking at fouling management, response to real-world factors like temperature, pH, and chemicals, and also strategies for startup and downturn, which are all real-world issues that we haven't looked at in details. Other PhD project on the right, the effects of urine diversion on sewage treatment plant performance. So we're going to take urine out of the sewers. How is that going to affect sewer processes? How is that going to affect sewage treatment plants? We believe that the energy consumption will be reduced, but also what are the effects on greenhouse gas balances and micropollutants. And finally, the project will be based on post-processing, so that whatever comes out of these pilot reactors can be post-processed into something that is more desirable for application in agri-horticulture or hydroponics, or and also more concentrated to be more easily marketable. So that's what we plan to do, and I believe that there's a lot of interactions possible with other universities based on this. These are the partners that are funding this part of the work, particularly urban utilities, IXOM, Southeast Water, and also our technology partner, AJJA, and Nutritrack Solution as our small boutique fertilizer company. So with that, I have concluded my contribution. Thanks for your time.
Thank you, Stefano. So if you have any questions, can you please type it in the chat box so that I can rely on that, relay on the speakers. Looks like when somebody is chatting, other people are not able to view it, but I don't know what the reason. But anyway, so let's please put the questions in the chat box. In the interest of time, I will go to the next speaker. It's Cara Bell from Professor Cara Bell from Griffith University. The floor is yours, Cara.
Thank you, Sherib. Good afternoon, all. I will just share my screen too. It's good to meet some of you. There's a few new faces here, so it's good to see that I think we've got some international visitors with us as well, which is terrific. So just let me know if everything is tickety-boo there. All good?
All good, yes.
Okay. So I'm I'm the kind of the lead researcher at Griffith University, which is in the southeast corner of Queensland in Australia. And I'll be talking to you today about some of the 3 key focus areas that myself and my colleagues, Associate Professor Saif Takar, Professor Anne Royko, and our newly anointed PhD student, Gail Newen, will be working on. So I guess the key for this really is you've seen a couple of these illustrations that we're looking at a circular economy. You've seen lots of circles. We're talking about systems thinking. There's lots of different parts to this. This is such an exciting hub to be in because there's so many different moving parts that need to be addressed, questions that need to be answered for all variety of components around nutrients in the circular economy. And we're looking at really the health side, the health-based risk assessments, some economic questions, and some regulatory aspects as well. Before I go much further, we'll be doing our work mainly on the country of Turrbal and Yurruga country, Yagara country. Also, we have lands, we'll be working on lands down in Uganda as well in the Gold Coast. So I and my Griffith University colleagues pay acknowledgement to the traditional custodians of the land and any Aboriginal and Torres Strait Islander emerging leaders and people here today. So that's just a little picky for where we are on the right there for maybe some of you international people who are joining us today. So the three key questions that I mentioned earlier for a successful, truly circular economy, for a truly circular economy of anything, you need to have a truly systems thinking approach. So we're not so much focusing on the technology side. Stefano and Sean have talked very ably and have some good history in this hub for some good technology expertise. We're hoping to kind of dovetail some of that with, as I said, some questions around is urine collection and reuse, is it economically feasible? Does it stack up? Is there a business case? Will people be attracted to it? Is there some financial return on investment? So they're really key questions really for any of this to keep going ahead. The other key thing that I think we can't forget, even, and again, Stefano mentioned it around the pharmaceuticals and maybe microbacteriological elements and so on within urine and the fertilizer processing is the risks to human health. And while they may be, or previous research has shown that they're relatively low, we really need to understand that for our third question to be answered, which is those regulatory and licensing requirements, those approvals that we need from our regulators, quite understandably, in order to make sure that this is a viable, a transferable, a safe and reliable process. So they're the three kind of questions that we're after. Yet again, you're going to see this picture a few times, I suspect, in the next hour and a half. This is really just to situate our work within the whole context of the hub. So this whole of system economics, as you can see, wraps around everything. Every single word or every single little activity or action within that inner circle will require some level of resourcing and funding, and everyone quite rightly wants to know, is it economically viable? There's not really a lot of information readily available yet. So if we want to widely adopt these urine diversion technologies, we need to demonstrate not just the financial, but the non-financial benefits to both the private and the public stakeholders. So that's where we'll be at. And obviously this knowledge will help to devise appropriate strategies and also promote, communicate and continue on this technological development, which we know is obviously incredibly important. But we need to make sure it stacks up in a number of ways.
I think we lost Cara.
Yeah, I think she's frozen.
Possibly Said, you can talk about how presentations like a little bit without.
Well, I can talk about the one that's on the screen at the moment. Yes. So hi, I'm Said Iftikhar. I'm also one of the CI from Griffith University. So well, now we're not the slide, but anyway. So we are looking at specifically. I will be looking at the economics aspects of it. And our GAM will be working with me on this aspect. So we will be looking at not only the market benefit of nutrient-derived nutrients and urine-diverted products, but also what is the non-market or intangible and social benefits of doing this kind of sustainable practice, and what is the benefit in that sense. And then finally, we will be looking at whether in a business case sense, does it make sense? And if it does not, like what kind of regulatory and financial incentives or measures that we need to take to make these products or make this system more acceptable. So that's, Sean, that would be my take for the moment.
Kara is here.
I'm not sure. Kara is not here yet. So probably I think maybe something might have happened. So I'm not sure. So, Said, is there any more that Kara has to speak or?
I'm not sure because there is another component with N, which is more on the risk side, but that's, I think, we're still shaping up. We are still looking for a PhD student to start working on that aspect. But maybe when Kara is back, maybe we can give her a space, maybe later.
Yeah. Okay.
Yeah.
That I think we can give Kara the time to speak later. So maybe I could, to go to, in the interest of time, go to next speaker, Professor Michael Duke from Victoria University.
Yep, we're ready to go. Okay. I guess if Kara gets back, can probably put her back on after my talk. All right. Hello, everybody. My name is Professor Michael Duke. I'm very pleased to be part of the hub and to get to meet you all. It's a very exciting opportunity because you're all mostly new faces, and I'm looking forward to getting to know you more and learning about the kinds of exciting research you're doing towards this great ambition. I'll just now, okay, share my screen. Okay, you should see that now. How's that?
Perfect.
Yeah.
Good. Okay, no problem. And I do the usual trick where the videos block most of the writing. Okay. So so yeah, I'm, as I mentioned, from Victoria University. I'm based in Melbourne, and we're going to work sort of coming back onto a more technology-focused theme, process development and demonstration for nutrient recovery from complex industrial solutions. And I'm talking on behalf of, I guess, our project team as well. We've got a PI by Oskakmak, who's from Parkway Process Solutions, who was in the list that Sean put up earlier. So we'll, I can admit Kara. Yes, come up. Yes, I'll do that. Okay. So this is all probably quite familiar to you, but I've got just a background slide, which kind of provides a bit of motivation to what we're doing. But resource recovery, or circular economies, has been a priority goal for industry for decades to recover as much value from its process and minimize disposal. And I say that because the various projects that we've worked with over the years, every company that we've run a bench testing or pilot trial or of particular technology, or done a desktop study, there's always the need or the interest to try and make the most of whatever's purchased and recover it and make some value out of it. But how you do that can actually be quite complex, and the challenges are just growing more and more. And we're never surprised to find out there's more examples of where this is already happening, and what we can do to learn from them is really important. For example, one that we've worked on in the past is with the dairy industry through projects through the ARC and Dairy Innovation Australia, which is now they've finished up. But in those early decades of the dairy industry, whey from cheese making was simply disposed. They were put under pressure to resolve it because it was creating a health and environmental problems. And now the recovered whey proteins are now a major industry for them, as well as the lactose. So effectively, the only thing left is the minerals that are waste in a sophisticated modern dairy plant. We also see biogas, as Sean pointed out earlier, so we're already recovering that for value. Biosolids and wastewater already with dilute nutrients. But as we keep extracting more and more from water, and this is the wastewater, particularly containing urine, and contaminants are a major issue, and the high dilution, so working with very dilute solutions is also the issue. So it just becomes too expensive. But with the advancements of technologies, with time, we can actually recover these quite economically. We just need to look at them again. So here's the team specific to our hub. So there's myself. My background is a technology background is membranes, and we've applied these for resource recovery in the foods industries and for water and energy savings in the various sectors of the industry. And also we've got Bahe Ozkakmak from Parkway Process Solutions, and he's brings in expertise of industrial technology commercialization, range of applications in biotech, energy and water and mining sectors. So where we're sort of coming in maybe quite closely into this hub is starting from around starting from a process that Parkway has been developing called AMES. And it's called the Mineral Extraction System, and it's an innovative process technology that enables the treatment of concentrated aqueous solutions to recover a range of valuable minerals, reagents, and fresh water. And it has applications in desalination, energy and mining, and other industrial sectors. So this information is available online, but broadly, you take an industrial feedstock, it's a waste, a concentrated solution, and through some various steps, you can extract the valuable products, remove the contaminants, and then further process these to make valuable products, which then can be sold on the market. And this process shows advantages, particularly around the resource consumption. This one shows just the water consumption and efficiency compared to other projects like it. And we've come out of another hub, which is called the ARC Hub for Energy Efficient Separation, which was is still currently coming to its end. It's at Monash University. And through that, we developed specific parts of the process together. And through, we're taking real feedstocks. So that's the major focus, is to look at real salts. In this case, these were kringulates in that particular focus, but just reminding that in coming into this hub, we're considering now broader ranges of industrial feedstocks, and we've optimized through the development, of sort of the innovative process and sort of recovery and purification steps and the conditions, and these then led to the development, the design and build and operation of a pilot plant, which is also based at our Werribee campus, which then we have a range of product samples which we demonstrate as outputs from the process. And it's an important part of this project to look at all aspects in relation to its feasibility. And that was, I guess, coming from Parkway's involvement, role in the project. While we looked at more just the process itself. So what we're looking at doing, and this exciting new opportunity with the hub, so between ourselves and Parkway, and we align under fertilizer theme 3, which is fertilizer optimization. So that was put up in Sean's slide about the hub theme. It's a 4-year project, and we have researchers already ready to go. So we've got Noel Dow and Peter Sancioli, who bring in the wealth of knowledge in laboratory work, analysis, and pilot operation, design and operation. Our project is specifically called an integrated water treatment process for valuable nutrient recovery and purification from industrial waste streams. And there's a range of technologies. So I gave the example before, which is very much inorganic or minerals focus, but we're also looking at organic processes. And I myself separately have been working on other processes and piloting them, for example, ammonia recovery on site from a wastewater treatment plant. So we're going to look at specifically innovative aeration and membrane-based technologies, including the MS I showed before, targeted at specific industrial wastewaters with nutrient value and potential. And the goals will be to, obviously to remove targeted contaminants that compromise these potential values. But specifically, as I mentioned before, with Parkway's feasibility studies, really looking at products. So, for example, we could produce fertilizers, including potassium and organic based. So we'll do this through, I guess, broadly a similar approach where it's a lot of lab work to optimize points to develop concepts and optimize conditions, which we then go ahead and look at designing and building and operating and demonstrating on the pilot plant, which is where the feasibility is realized. So we have these facilities between us. So for those of you who don't know Victoria University, well, if you knew Victoria University, you do know about the Werribee Campus. We're over here, over near Werribee, so here's Melbourne. If you're familiar with water treatment, you're probably familiar with the Werribee Western Treatment Plant, which is just here. So we're based here, quite close, and Parkway's office and floor space is based in Sunshine. And together we'll be able to work together quite closely to do all of the work proposed here. So thank you very much for this opportunity, and I've just got a photo there from the launch of the Energy Efficient Separation Hub, Sean. So it was an exciting event. I'm sure yours will be as exciting and possibly more with the ministers and special guests. So looking forward to seeing you all there, or if it'll be virtually, will it? I guess not in person. But in any case, get a good time to catch up and look forward to working together with you all on this hub, exciting hub. So thank you very much.
And thank you, Michael. Thank you very much for keeping within the time. So, as they will leave the questions to the last, and we have Kara back. So if
Yes.
continue your presentation, so we just lost. Yeah, Said was talked briefly about economics. So, but yeah,
Oh, thanks, Said. Okay, thank you, Sharon. Apologies to everyone. I'm not quite sure what happened then. I might be telling my teenagers to get off their gaming when I'm in the middle of a presentation. So that will be a fun conversation later for them. Right, moving right along. And thank you, Said, for filling in there. I'm not too sure where you got to, and I think I talked to myself for a lengthy couple of minutes there. Let's get on with it. So here we go. Get to see all of that again. So here is some of those research questions, Syed. I don't know whether you talked to them, but really this is just some of the questions that they're draft at the moment. We haven't really bedded them down, but just to, I guess, just to share our thinking is looking at some of these, the key factors that influence the supply and demand of the products and services. What are the market benefits? What are the non-market benefits? Are urine diversion projects cost effective in terms of the value chain analysis and business cases? So we want to look across the whole of that value chain, and there's many moving parts on that. And what financial and regulatory strategies can be applied to promote urine diversion projects at different scales or contexts. So that nicely dovetails into some of the regulatory approvals and discussions we'll be having with our friends at the state government legislation areas. And the way we will look at these methodologies are pretty tried and true approaches. Some market analysis, non-market valuation. We'll have some stakeholder interviews, key informant interviews, workshops, and so on. And this will be done primarily through, or our work will be done primarily through 2 separate PhD scholarships. This will be the first one, first cab off the rank. As I say, Queensland Water is our main collaborator with this. And we are just finalising our PhD student, Gab Newen, who I think will be very, very able in this area. So the second, I guess, question was the health-based risk assessments. Professor Anne Royko will be leading this one. And this sits around regulation, but it sits around a number of, I guess, different factors. We want to make sure the collection, the treatment, but more so, I guess, that end use and that application, and where the fate of any contaminants that might be in the urine, where that might go, and how they may be attenuated or removed, or certainly really lower that risk. Again, there are no guidelines defining the adequate treatment of urine and the safe use of urine-based fertilizer products. And I think this is because when we're talking about urine, we're talking about liquid gold, we're talking about this yellow water, and we know what's in black water. We know what's in grey water, but yellow water is a bit more of a moving beast. So it's really looking at a systematic health risk assessment to find the efficacy of the removals, and also any potential effects to soil ecology and health, ideally, if we get the time. But certainly that first bit will be for human health. Our collaborators here will be local government, Brisbane City Council. We're just working on getting on board. And there'll be other LGAs and other state governments and utilities across Queensland, New South Wales, possibly Victoria, that we'll be working with to really understand some of those health risks and the health concerns from the regulatory government as well, from the regulatory departments as well. What are their concerns and how can we address and reduce and minimise that risk? That will be undertaken by a PhD student who we are still in the process of engaging, and chiefly our research methodology will be, well, our research approach will be looking at quantitative microbial risk assessments, which Anne and her team are very adept at. So I won't go into too much detail here. There's a little bit about the approach. Essentially, it's looking at this human health risk. So it's a risk-based approach, and we combine that with hazard analysis critical control points, this HACCP, which is looking at what point along this treatment train are there critical points that we need to understand the health risks and manage those health risks in order to reduce any risks of disease. So that's our second big project, and I think that again that will really dovetail nicely into our third area of focus, which I'll be looking at. Is the regulatory approvals and ideally mainstreaming these sorts of processes into mainstream legislation. And the rationale for this is if you see here, we've got the regulator at several points across this system with those orange arrows. So across pretty much all part of this project, the regulatory bodies will be looking with interest. And I know with my previous experience in this space, back in 14, 15 years ago, when we did some work at the Currumbin Eco Village around this, where there has been research exemptions by our regulatory authorities. We don't want just exemptions, and nor do the authorities that we've spoken to so far. They're happy to go, well, let's mainstream this. Let's not keep doing ad hoc research or short-term approvals. Let's truly understand the processes and the risks and what needs to be assessed and what needs to be approved, and let's try and make it happen. So we've had some really positive feedback from our stakeholders, our relevant stakeholders here. So again, lots of local government with collaborators, both from the hub, and we'll probably be talking to people outside the hub as well. Certainly Department of Environment Science in Queensland, Energy and Public Works, Queensland, New South Wales Health. Again, urban utilities have been very helpful and will continue to be. So our focus is, identifying and addressing these regulatory approval requirements, and the approach really is to identify the components of across that train, that treatment and reuse train, work out some of the timing and the details and the approvals and who needs to do what. Our initial work has shown that different approvals will be required for different parts of the process. Our first meeting, sort of mapping that we had here, it's just preliminary mapping, so I'll probably ask you not to take photos and send them around because this is really very draft at the moment, but it's really looking at different stages: the collection, the storage, the processing, the storage of that liquid fertilizer, and then the application of it will require different types of approvals, and we're working through that now. But we've got really good buy-in, and there's a really good feel from our regulatory friends. They want to make this work, so that's really good. So they're really the three key focus areas for Griffith Uni and other hub expertise and our partners. And we're kind of hopefully covering, as I say in my title, really looking at that systems approach to what other parts of this really tying in together some various parts of this systems thinking around this NiCE hub. And there's a nice picky of Anne and Syed, because you've seen my face, and there are three researchers at Griffith Uni. So I will leave it at that, and hopefully when we talk more in November, we might have a second PhD student on board and a little bit more to discuss. Thanks, Cheryl.
Thank you, Gara. Thank you very much. So we have enough time to do the discussion. So if you have any questions I didn't see any questions here. But yeah, it is open to the discussion now. So I just before you prepare for your own questions, I just to start the discussion here. So Kara, you talked a lot of a very diverse portfolio for this NiCE research hub, and all this economics, and then value chain, and also in and all this risk assessment, and so the regulatory ones. So when you talked all about, for example, especially about the regulatory ones, you look a lot of data to back up your let's say approval processes. So wondering how you're going to be collaborating with the other the hub members, CIs, because you probably require a lot of data from the risk assessment, the safety, and then also the technology, how it works, what the characteristics,
Yep.
the characteristics of the fertilizer, and even probably the process, how it is done.
Yes.
So you just want to have what sort of idea you have for collaboration, cross collaboration, and also what sort of support that you are looking from the hub to improve this cross collaboration. So yeah, if you can just shed light on this one.
No, that's a good point you make, Sherab, and that is the beauty of being in a hub that has 7 universities, 23 industry partners, and 3 international partners, is that there is a lot of data and expertise out there that we can draw upon and use. So the first thing, but how to do it, that's right, exactly. It's always easy to say, well, we can, but doing it's always a harder thing. But some of my thoughts around that is we're going to have a second meeting now that we've mapped out kind of the different parts of that train that will need specific regulatory approvals. The second thing is to then nut out again, probably we'll have one more meeting just with those key regulatory stakeholders about the exact information, what is good enough information. And really they've asked us, will you tell us, because they don't know, you tell us what you think we might need to know about different parts of the process train. And then we can once we've kind of clarified that a bit, we can then go to the relevant partners within the hub and probably ask, we'll give a bit of a wish list to yourself, Sherab, or whoever's the hub manager, and say, okay, these are the types of things we need to know. This is the data we need to know. And then have some sort of and I hate to say it, an online workshop-y type thing where we get a bit of a whiteboard together and I get a feel for who is holding what data and how we can use that to bring together some really good information to go back to our regulatory authorities and say, okay, this is the bounds, this is the maximum minimum of what might occur in terms of, and that's something else we have to work out with our health risk assessment as well, is that some of that data we don't quite know as well. So it'll be a bit of a moving dynamic thing. But I would say, firstly, identify exactly the type of data, and then secondly, make a call out based on some of the information that we'll learn from today and that you'll know who holds what, and then get together and have a bit of an online discussion and whiteboarding around that, just off the top of my head. But it's a good point you make, and it's definitely, there'll be quite a bit of consultation.
Okay, that's great. Yes, I can see that many people are nodding head, because there's a lot of opportunities for your group to collaborate with others, because a lot of things that you can share with each other, because it's because your work, probably some of the works rely on the data from the CIs. So
thank you.
So before I go to other questions, so let's have a photo session, because I forgot to do that earlier. Maybe if you can, everyone can put on your camera, and that just I can screenshot so that we'll have a record of what we have done. Just hold on. Okay. Okay. Yeah. Bezat, are you there? Looks like.
Yeah, I'm here.
Okay. Oh, there are 2 of you. Okay. Okay, just hold on. Let me screenshot. Okay, everyone. 1, 2, 3. Smile, everyone. Just hold on, one more. Just in case if someone closes their eyes. Okay, one more. Where is this? Okay, 1, 2, 3. Smile. Okay, thank you very much. Okay, so now let's. I want to open the questions for other audience. So if anyone wants to raise any questions here, you're welcome.
So Kara, just wondering that when you focused on the urine, your overall health risk assessment, also your research approach. So when you have this kind of approach to the like industrial wastewater, so Michael Duke, he collaborated with the Parkway, and then they are very much focused on the wastewater, especially the industrial, like a protein waste, daily wastewater. Also, they produce a lot of wastewater for the fertilizer, potassium-based, organic-based. So this concept you mentioned about specifically urine, whether this can go to the also Michael's fertilizer production concept as well. Like he's talking about daily wastewater and the fertilizer production. So how this will different from the urine approach?
Was that to me, Sean?
Yes, yes.
Sorry, I hadn't quite put my headphones back on from our paparazzi event. It's good point. I mean, it probably won't. I don't know. It probably won't differ that much, and certainly that will be. Yeah, that's a good point. That you're probably more of a comment there, I think, or a gentle suggestion. I get together and talk to Michael about that, and I certainly will, because I think there'll be a lot of alignment there. I think, as I was saying earlier, when I got the research exemptions with the regulatory guys earlier. A few years back, it was because they just didn't know quite where to put this urine box, this yellow water box, because particularly with the pharmaceuticals and all of this, the antimicrobial resistant contaminants and so on and so forth, pollutants and so on. So there is, I think, one of the things that might differ, maybe not, but is that lack of known. There's just this feeling from the health guys that it's just an unknown quantity, whereas perhaps the other waste streams you mentioned is a bit more of a known quantity. I don't know, but I certainly will. I'd love to hear from Michael about that as well, and certainly don't want to reinvent the wheel or make more work for ourselves. So that's another good point, Sean. Thank you.
Yeah, and thanks, Karen. I think what you're doing is really important. I mean, I'm thinking of working across various sectors. One I'm more familiar with is the use of reuse of wastewater and the guidelines and the regulators associated with that. But we've been also working in foods, and I'm interested, Sean, like you put up your process where you're irrigating like lettuce or something, right? I mean, is there a certain point where it gets into some sort of foods regulations as well, and what you can do? Because I know there are certain times where you don't need to do anything but no, there is a catch that as soon as you produce, if it's a waste and you treat it, then you have to start following certain guidelines and so forth. So it's a very much case by case as to who you need to activate, but we'd like to consider all, because we're crossing quite a few industries here. Yeah, Sean, what did you think? What are just in your one with the lettuce? I mean, before you start eating that, is there anything you need to do? Maybe it doesn't matter if it's all, just for you, right?
I think that's one of the good expanded research activity from the Griffith University. So we just focus on urine, but now it's another opportunity. Your fertilizer can be from the industrial wastewater source, like a dairy cheese or some other potassium-based, or some of the lake, I don't know, the halloysite or silivite or leonite, this kind of all the lake from the fertilizer, also industrial wastewater fertilizer. So how this can make a little bit more health risk as also some of the guideline we can make happen to commercialize your product. So that's the collaboration the Kara can work with the Victoria University, and that you can make some more expanded scope of this project.
Yeah, that'd be fantastic. And that's what I was thinking too. And I saw your talk, Kara, that once with Givens, started to lay down some applications, those sorts of things are going to emerge. So I really see, we're at the beginning of something really cool. So yeah, it's good to have that contact. Yeah. Yeah,
it's great. It's good. Yep. It's good to hear your talk too, actually.
Well, thank you.
Also, Michael, yes, based on your presentation, still, I'm not really 100% sure the potassium-based fertilizer. So where is this main potassium fertilizer is from? Which kind of wastewater source you have? Also, you mentioned about halloysite and then sylvite and then leonite from the older precipitant. So this is based on what kind of fertilizer you are producing?
Okay, that's right. I'm so used to calling them by their crystal names that they're common names that I forgot. Halite's just sodium chloride, sylvite's potassium chloride, and of course SOP is potassium sulfate. So that's sort of really coming out of the potassium focus was really coming out of that project with focus at Kringa Lakes, where that was the focus, but the process itself through its various steps that we had to develop and optimize all of them can actually target different elements or different minerals for different applications. Potassium is certainly a focus, but it can target others. So if and that's where the focus is right now is we've got a few industries in mind, and if there's a mineral aspect of it, the process can use can basically extract the minerals of interest that highlight in those, and there's different ones, and but we're also looking at organics as well. So the potassium in that particular case was sourced from salt lake brines, right? And through the process, through multiple steps, produces potassium sulfate or potash, which is a fertilizer product. So it went all the way through.
Do you have any specific application of your fertilizer in your mind? Have you ever
well, once it's a potash at a certain grade, it just becomes market to. I mean, potash is a very well-known fertilizer, so I think if it could be used, yeah, that's right. If anyone's got a particular place they want to use it, but it's meeting certain requirements as commercial potash, so it should be the same as where you buy potash normally. Yeah. But that's actually one thing that could be really cool. So what we if there's a particular demand for some fertilizers or interest for fertilizers, that can also help design some of the aspects of the process.
Okay, thank you. Any other questions for the four speakers? Okay, so because we have some other CIs who haven't introduced, so I just want to take this time to introduce, because all the speakers they already introduced themselves while speaking. So I want to introduce the other CIs. Leonard, maybe you can just, Leonard will do it during his session time. Professor Biggie, so you want to briefly introduce? Yeah, you're muted.
Yes. I have been with UTS for the last 31 years, and I've been fortunate to work with Sean and all the number of professors at UTS. And this particular project, I will be helping the UTS researchers as well as UTS CIs, as well as other CIs on the membrane bioreactor-based pre-treatment or any other membrane-based or physicochemical-based pre-treatment systems to reduce the fouling and especially the biofouling. And I also will try to sort of work on the automation aspects.
Okay.
So I have been closely working with Sean, and I will be working with Sharuf and Leonard. So I'll be sort of all the time with you all. Thanks.
Thank you, Professor. So I'll go to next. Saeed, if you can briefly introduce, because you spoke earlier, but yeah, if you can introduce.
Sure. Hi, I'm Said Iftekhar. I'm based here in the Griffith Business School. By training, I'm an applied and environmental economist. As I mentioned before, I'll be working on the whole of system economics project here, which is called O1, if I remember correctly. So we'll be looking at what Kara has already said, that we'll be looking at the total value and these business cases of these types of products and services, urine-based products. But we'll try to focus, incorporate more of the non-market value part, because the market part, like market data, often is quite easily available, but it's difficult as to what is the demand and what is how much people are willing to pay for these kind of sustainable practices. That would be the challenge, and that's why we'll focus more on. Thank you.
Thank you, Saeed. We have, okay, Behzad, yeah, I want to introduce. Behzad, are you there? Okay, seems she's not here. Who are other one? And Dana will be introducing, because she will be presenting, so she can introduce herself later on. So any other, I can't find the name, Nigar's phone and Vira's Kusoke. Any other CIs want to introduce, because I cannot.
Jason?
Jason will be presenting, right?
Okay.
Yeah, Jason will be presenting. There are two Jasons, or we have only one Jason, right? From UTS. Oh, you have other Jason from other university, yeah? Griffith of okay, let's wait for Jason. Jason Reynolds. Are you here? If you can present.
Yeah, I'm here.
I'm sorry.
That's fine. I'm Jason Reynolds. Jeff Powell will be talking later on about our work, but I've focused for the past few years on putting recycled water and biosolids onto the soils in and around Western Sydney. So those aspects around potential hazards, a hot topic in the Sydney Basin at the moment. And Sydney Water is the major water utility in the Sydney region, and they've been funding a lot of our research. So we're very interested in issues around placing these products onto the soil surface and watching to see what happens, both directly to the crop system or the horticultural system and to the landscape.
Okay, thank you, Jason. Any other CIs? Okay, Jillian was here. He's gone, looks like. Okay, that's fine. Ibrahim, can you introduce briefly yourself? Yeah.
Hi. Hi, I'm Ibrahim Salibi. Some of you know I work for the Botanic Garden. I've been helping Sean with this project in the last few months, and we've been collaborating with UTS for the last 10 years, using fertilizers from FO technology first. Then we used recently the Ervil and growing lettuce and bok choy in vertical garden and in hydroponics. And we also tested the fertilizer on parsley and some ornamental plants. So yeah, my background is agriculture, and I've worked in water treatment for a period of time and then in horticulture. So I'm trying to use all this knowledge to help Sean achieve the targets of the project. Thanks.
Thank you, Ibrahim. Behzad, are you there? Okay. Okay, so Bezer is not here. So yeah, if you have any questions, we still have few. We can allow a few minutes to further discuss. Any burning questions for our four speakers earlier?
Hello, it's VG again.
Yes, please.
Can you hear me? Yeah. So I have been speaking to these industry people. They are asking the question whether the system which we are going to develop or we are in the process of developing, whether it can be retrofitted in the existing infrastructure or it is only applicable to the new infrastructure.
Okay, Sean or Stefano wants to share on this one.
I think we can. That's the one of our objective of this AIC NiCE Hub. So we are considering the retrofitting system because this is more cost effective rather than just building the new and then just install our urine diversion system. So retrofitting existing toilet system, how we can make a cost effective way of the urine diversion. So that's the currently ongoing the project objective. Also, that's the possible depending on what's the building you have your own toilet system. So we will consider this one, and then this is possible, but depending on your toilet system, so that we can make sure that the more cost effective in terms of our urine diversion and fertilizer production and application system when you have a retrofitting, or if it's not really cost effective, as well as some of the safety concern of the building structure. So we don't recommend the retrofitting. So it depends on how your toilet system looks like for your building.
I think that I agree with Sean. It really depends on the building. It's very hard to retrofit a high rise, impossible. But I think the transition towards urine diversion is not going to be one that will be over 5 years. It's going to be most likely over 20, 30 years. So I think that at the end of the cycle, hopefully new buildings that will come up will be designed with urine diversion already from the start. So that at that stage, we'll be moving into a full circular economy.
Okay, thank you everyone for sticking to this first session. So we'll have short break. So probably 5 minutes should be fine, I think. So we'll resume at 3:52, 53 or 3:50.
Let's make it 3:55, sure, yeah.
Oh, 3:55, okay, that's fine. 3:55. Yes, please have coffee or whatever you want. So we resume at 3:55. Thank you very much.
All right. Hello again, everyone. Good afternoon. Can you hear me? Yeah. All right. Thank you very much. All right. So we're going to start our second session. Let me introduce myself first. I'm not sure if everybody's here already. May I just check? There's a lot of people without videos. So I just would like to know if you are there so that we can start properly. Can you just show yourself for just a bit and then, all right. Wonderful. Wonderful. Thank you. Great. So again, good afternoon, everyone. My name is Leonard Ting. I'm a senior lecturer from the University of Technology, Sydney. I'm also one of the CIs of this hub, but at the same time, I'm also the acting hub manager for now. I guess many of you may know my name already, and this is the first time for some of you to see my face, but I'm that annoying guy who's always chasing you up for reminders and getting Hanisher C's and all of these agreements. So good thing we're almost there, or we're going to start our hubs very, very soon. So still you will not, I will not stop sending emails anyway. Anyway, before we go to our second session, I would like to first also acknowledge some of the people that are with us today. Just to give a brief of introduction from people, just for everybody to know each other. Aside from the speakers, I'll just have to ask, may we know the one with U1058119, if you could possibly introduce yourself, if you don't mind. I'm sorry, I caught you, you are eating a bit, but yeah. Hello, you there?
Yes, I am muted.
Yes, please.
So
yeah, can you please introduce yourself?
I'm Sergei Marchuk from University of Southern Queensland, and I'm working with Professor Bernadette Makabe on application of different organic amendments to soil. So my specialty is I'm a soil scientist, so I do all field work and research with soil.
Wonderful, thank you. Sorry, we didn't. What's your first name again? What was that?
Sergei Marchuk.
What? Okay. It's a little bit hard for me to probably pronounce the last name, but yeah. Welcome to the hub for this summit. Yes. Bizad is here. Can you please introduce a brief introduction of yourself, Bizad? Thank you.
Yes, sure. Good to see everyone. I'm Behzad Fatai. I'm the associate professor at UTS in Civil and Environmental Engineering School, and I work with another colleague, and I'm a CI working on use of the treated urine for improvement of the soil under our infrastructure, actually. So we would like to reduce the cement usage and bring urine for treatment of the material, make them stronger and more durable for road, airport, railway construction. So I will interact with you more, and very fascinating field actually for me. Thank you.
Thank you very much, Bizad. There are some more people here. Can you please introduce yourself, Chi Shang Chen?
Hi everybody. I'm a PhD student under Dr. Stefano. I'm from University of Melbourne. So currently I'm under the supervision of Dr. Stefano, been doing the impact of urine diversion to the sewage treatment plant, as well as our sewage system. And we wish to quantify whether the urine diversion is impact to the removal of micropollutants.
Thank you very much for that. It's good to see that some PhD students are actually joining us here today. Thank you. Janice Antil, are you there? Janice Antil, yeah.
Yeah, thank you. Dio Antile, I'm from CSRO, based at Canberra. I am within the Soils and Landscape group here, and I got an adjunct position with USQ in Toowoomba. So working with Professor Bernadette McCabe.
Wonderful. Thank you very much, dear Janice, and welcome. We have Vera Kuskoi, please.
Yes, hello, good morning from Finland. I'm from Tampere University.
I'm just about to finish my PhD here. Stefano is one of my supervisors for my PhD. And well, I'm not officially a part of the hub as of yet, but I have a long history, or well, my PhD has been focusing on nutrient recovery using these bioelectrochemical systems.
Thank you very much. Oh, sorry about that. Go ahead. Yeah.
No, nice to meet you all and good to be here.
Thank you, Vera, and nice to meet you as well. Aline, please. Aline dos Passos Silva.
Yeah, hello everybody. So I'm a master's student here at UniSQ. I'm working with Professor Bernadette McBee and then Serhi as well here at the Center of Agricultural Engineering. So then I'll be participating in this project as well.
Thank you, Aline. Nigar, please. Nigar.
Yeah. Hello, everyone. I'm very happy to be in this meeting. So I'm Negar Dasine, and under supervision of Dr. Stefano, I've started my PhD journey. So what I'm working is nutrient recovery based on bioelectrochemical technology and electrodialysis. So we mainly focusing on basically comparing these technologies and trying to improve the performance to produce a very high quality fertilizer for the land application.
Thank you, Nigar. We have a few more. It's okay because we are missing one speaker later on, so we're just on time. We have Omakan. Just a short introduction, please.
Yeah, sure. Hello everyone, my name is Omakan. I'm a PhD student at UTS under the supervision of Sharub and Sham, and I work on impact of urine diversion on wastewater treatment.
Thank you, Omakan. Jay, please. Jakshi.
Hi everyone, my name is Jessie Jiang. You can call me Jade. So I'm a PhD student under the supervision of Professor Sean and Dr. Shira. So my research interest is to use bioreactors to treat the salt-saturated urine. Thanks.
Thank you, Jade. And Wonjung.
Hi, I'm Wonjung Son. I'm a first-year PhD student under Professor Sean's supervision, and I'm working on the urine nitrification in a membrane bioreactor and further concentration by RO to produce the fertilizer. Yeah, happy to meet you, everyone. Thank you.
Thank you very much, Wonjung. And I think the last one is Abdul. Are you there?
Yes. Hi everyone, I am Abdulaziz Mtashri from Saudi Arabia. Currently, I'm a PhD student at the University of Technology, Sydney, under Dr. Shurub and Professor Sean supervision. I'm working on removal of pharmaceuticals from urine by using granular activated carbon. Thank you.
All right, thank you. So the next one would be from Western Sydney University. We have Jeff Paulo. Can you please introduce yourself briefly, Jeff, and also your team? Thank you, and you present, please.
Sure. Just share my screen. Are you seeing the right view, the correct view?
Yeah, sure. Yep. It's good.
Okay. Cool. Thanks, Leonard. So at Western Sydney University, like most of the all of the other presenters, the work that's being done in each of the different groups, it's definitely teamwork. So at Western Sydney Uni, it's myself and Jason Reynolds. So we're both largely focused within theme 4, which is fertilizer end use. So we're one of the groups that's largely focused within that theme. You're going to be hearing Bernadette scheduled to speak after me. So you're going to be hearing from one of the other groups that's largely focused within that theme. Jason and I have complementary skills. We both have a very soil-centric approach to our research. Jason from a geochemical side, myself from a biological side. And both of those different aspects work together to influence soil biological fertility and how nutrients interact with the organisms that are living in soil and the physical and chemical structure of soil. Because we have this soil-centric focus, so much of the research that we're going to be focusing on is trying to quantify benefits associated with urine-based fertilizers. And because we have this soil-centric focus, it really, we see it as really depending on the context in which the fertilizers are being applied. So in very productive soils that are well drained, these are the types of systems that we've largely been hearing about. So soils that are used for agricultural, horticultural production, where the benefits are largely around production of biomass. Okay, so growing more forage, growing larger trees, growing more fruit, etc. With also a potential side benefit of actually adding more soil to carbon. And that's something that I'll be coming back to later on in the talk. There are specific issues associated with these soils as well. These issues are associated with urine-based fertilizers, but in some cases they're associated with fertilizers in general. So one of our aims will be to determine whether some of the issues that we're facing applying urine-based fertilizers to soil, whether they're unique to these fertilizers or it's just a consequence of fertilizer use. And so these, in those well-drained soils, it would be issues associated with leaching or losses of nutrients via other means, so ammonification or incomplete nitrogen cycling. And so in general, in soils like that, what we're going to be focusing on is trying to really understand the behavior of those nutrients, once they end up in soil, what's their behavior in terms of the degree to which they absorb to the soil particles, what's the capacity of the organisms that live in soil to take them up and to assimilate them, etc. But then we've got a whole bunch of other different soils, soils that are used for agriculture or horticulture, but are really quite marginal. And so in and around Sydney, we work on a lot of soils that have really poor drainage. And when we're growing plants on those soils, one of the key issues will be reduced plant health as a result of presumably increased salinization of those soils. And we're keenly interested in ways in which we could potentially mediate that. So for example, if we could modify rates of fertilizer application or timing of fertilizer application, or choosing what plants we're using for forage production or for veggie production, etc. And then we've got our really damaged soils. And so there hasn't really been much of a focus on these types of systems yet, but we think that there's an opportunity here to really help to restore and help soils to recover. So we've been working on some really heavily impacted soils in Western Sydney, quite compacted, very low nutrient availability, very low carbon content, very low biological fertility. And we think that there's an opportunity here to use some of these products to really enhance the recovery of these soils. And so there's some research needs associated with those. I'm going to contextualize some of these just by referring to some of the work that Jason and I have been doing with Sydney Water, where we've been looking at wastewater and recycled water and how it can be used to, whether it can be used and to the extent that it can help improve soils. So this is a couple of photos from one of our field sites. So this is a paddock. You can see that it's irrigated. We've got some irrigation heads all throughout the background. We've been describing these soils, describing the characteristics of these soils, as well as looking at using these lysimeters that we've been making out of these soils to look at the behavior of nutrients that are present within the water sources that we're using, and the impact of those on the whole soil system. And so this is, we've been looking at this across a range of soils. So we have some of our more productive soils. So here you can see one where we see the top 30 centimeters. There's quite a bit of organic content in that soil. This would be a soil where perhaps we want to utilize these fertilizers in order to enhance the productivity of the system. We've got some other soils that we're looking at, really challenging soils to work with. So in this case, this is a soil from around Penrith. They have been trying to plant trees in this soil for a while with very low success rates. And so one of our aims in terms of working in these other projects that we've been working with is seeing if we can improve these soils to increase the success rate of those plantings. And then here's another example of another soil. It's a very poor structure in both the surface layers, and as you can see deeper down in the soil, there's poor vegetation cover here. In both of these last two soils that I mentioned, we've identified that there's actually a lot of opportunity here, particularly with regard to building up soil carbon in these soils, and that when you do that, you actually enhance the fertility of the biological fertility of those soils as well. And so that's one of our aims, is to try to quantify the degree to which we can enhance those things. So one of the aspects that we're looking at is, so how can we mediate nutrient losses from these systems using, where we're applying urine-based fertilizers. So that can be via, those losses can come via leaching and runoff. The key issues associated with those have to do with the physical nature of the soil, its texture, how much organic matter is it, how much what degree it's compacted, and to what extent do roots and microorganisms grow within those soils. And so approaches that we might take using these fertilizers is to experimental approaches that we might take to see the extent we can maximize or minimize these issues, is to change input rates, add these fertilizers in addition to other organic amendments. Plant choice is also an important thing there as well. The other two bullet points here relate to other aspects of the work that we're planning on doing. I won't get too in depth into that, except to say that we do want to focus on doing what we can to see how we can make sure that these plants are making the most of the nutrients that we're providing, and that we're not actually creating more problems related to the evolution of greenhouse gases. We don't actually want to enhance those things. I mentioned with regard to this potential associated with improving soil carbon. So again, this is relating to the work that Jason and I have been doing with Sydney Water. So these are four of the soils that we've been working with. And there's some preliminary data that we have here where we've been showing the degree to which we can build soil carbon by adding stormwater or one of two different sources of recycled water. And just over a relatively short period of time, over a few months, we've been able to see some increase in soil carbon. And so one of the things that we would like to do is to see if we can enhance that using these fertilizers. Something that's really promising, the image on the right. So this is showing how much, this is showing microbial biomass carbon. So the extent to which we get an increase in some of those organisms that live in the soil and interact with those nutrients as well. And so in some of the poorer soils that I've been showing you, we can actually see some pretty large improvements in that biological fertility. And then the other aspect is, I mentioned already, salinity. And so one of the aspects that, another aspect that we'd like to look at is in some of these soils where salinity might be important, what are some plants does the choice of plants that we're using in these systems influence their capacity to tolerate increases in salinity, and are they able to utilize those the nutrients and the fertilizers efficiently? So just last slide, it's just a brief summary. So there's lots of benefits, potential benefits associated with these fertilizers. There's also a lot of potential trade-offs associated with them. So in some soil systems, some of the benefits that we might get might trade off against some undesired outcomes that we might have. And yeah, so we really need to think about, for particular soil systems, what is our goal? So for a healthy, well-draining soil, we might have one goal, but we do have a lot of opportunity to actually try to repair soil as well. So I'll leave it there. And thanks everyone for listening.
All right, thank you very much, Jeff. Yeah, for keeping the time as well. Thank you. All right, so for the next one, we have Professor Bernadette Macabe. Unfortunately, she sent her apologies for this afternoon's session, but she sent her recorded video. So we'll be receiving to a recorded video for her plan and project. And Cheryl, will you please share that video? And I think some of the students coming from University of Southern Queensland are here as well. So yeah.
Welcome to this afternoon's session on the first Nutrients in a Circular Economy Summit 2022. My name is Professor Bernadette Macabe, and I am the Director at the University of Southern Queensland's Centre for Agricultural Engineering.
You can hear me, right?
Here
But hear the
in
video, right?
Toowoomba. Today,
yes, it's okay.
I'll give an overview of the work that we will be conducting as part of the ARC NiCE Hub, and that is regarding the optimization of urine-derived and Biosolus-derived biofertilizers. Before I begin, I'd like to introduce the project team. I will be leading the project as Chief Investigator, and we also have a support from co-investigator Dr. Dio Antil, who is an adjunct research fellow at the Centre for Agricultural Engineering at UniSQ, but is based with the CSIRO Food and Agriculture Business Unit in Canberra. We also have Dr. Serge Marchuk, who is a research fellow within the Energy and Bioresource Recycling team at the Centre for Agriculture Engineering, and also the support of Ms. Eleni dos Pazos Silva, who are also providing research assistance along the way. Now, the biofertilizer work is contained in 2 work packages. Work package 1, which aligns with project 4.3 in the ARC Hub, will look to evaluate and demonstrate UGOLD and Ervil efficacy in field trials, and we'll be partnering with urban utilities. Work package 2 is Logan Home Biosolus Gasification Project, which has received the financial support from Pyrocal, Pty Ltd, and also Logan Water and Logan City Council. Both Work Package 1 and Work Package 2 will be providing information around the usefulness of both urine-derived fertilizers and biosolids-derived biochar, which is going to be really important in understanding end-of-waste codes. So both work packages will be working closely with Queensland's Department of Environment and Science. Just looking now over to project objectives, I'll first of all look at work package 1, which is looking at the evaluation and demonstration of UGOLD and Ervil efficacy in field trials. This work package has 2 main objectives. The first one is to develop the specifications for novel urine-derived biofertilizer products that firstly meet the requirements for field application from a physical property perspective, and then secondly, looking at a biofertilizer product that also meets nutritional needs of plants, and therefore we will be focusing on the chemical composition side of things there. The second aim of work package 1 for urine-derived biofertilizers is to experimentally evaluate the proposed formulations and product format to determine the fertilizer replacement value, or FRV, of the urine-derived biofertilizer products, and develop guidelines for use on crops and parklands. The second work project is called the Logan Home Biosolus Gasification Project. And again, under 2 main project objectives, we'll firstly look at understanding the effect of a conversion technology called the continuous carbonization technology on heavy metals content and mobility in a byproduct. Firstly, by assessing the potential risks due to heavy metals, namely zinc, chromium, copper, nickel, and lead. And then looking at the nutrient effects, primarily nitrogen and phosphorus, leaching in soil treated with the byproduct. The second aim of work package 2 will look to determine the suitability of the byproduct as a biofertilizer. We'll be doing this by looking at 2 key areas. Firstly, the nutrient availability of N, P, and K from the byproduct to soil. And secondly, the byproduct as a potential fertilizer with respect to plant yield by determining the agronomic response in interconnected studies involving glasshouse and field experiments. In terms of the methodology, I thought I'd just outline it by 4 points, which will be generically applied to both work package 1 and 2. So first of all, we'll be undertaking an agricultural requirements analysis by comparing both the biofertilizer against the inorganic fertilizers. And this is important both from a contamination point of view and also a nutrient point of view. So in regard to heavy metals, we'll be also assessing the heavy metal contents of synthetic fertilizers as well, as this will become important when we're assessing regulatory guidelines. We'll then secondly develop product chemical and physical specifications that will help to inform the product development of both the urine-derived biofertilizer and Biosolus-derived biofertilizer. And then from those specifications, we'll look to evaluate the proposed formulation by conducting agronomic studies at both field and glasshouse scales. And then with all of these points combined, we'll provide results which will then go into the development of guidelines for efficient and safe use of both biofertilizer materials. If we look at the first point of our methodology, we'll be looking at contamination studies in terms of the heavy metals, particularly around the Biosolus-derived biochar. And then we'll also look at the agronomic performance, particularly around nutrients in glasshouse trials. And so we can see here at the top image to the left, we have facilities and laboratory which will be undertaken in terms of leaching experiments. We will be conducting those primarily to assess heavy metal mobility in Biosolus-derived biochar. And to the right here, we have an image of the types of glasshouse trials that we will be conducting in our facilities. And these will be done to determine the yield to nutrient response relationships for both the biofertilizer materials that we will be investigating in work package 1 and 2, and then to compare with the standard mineral fertilizers such as urea. And if we look at the glasshouse trials, we have previously conducted trials with biofertilizers which have utilized ryegrass. And we use ryegrass because of its ability to grow quickly and the ability to obtain multiple cuts in a short period of time. So we'd be looking at setting these up quite soon, probably to, in order to take the right season, we'll be looking to set it up around mid-August and run it right through to summer. And what we'll be doing is taking dry yields from all those treatments that we were doing and recording monthly in order to establish relationships with amount of nitrogen and phosphorus supplied. So we'll be doing these both for urine-derived fertilizers and also Biosolus-derived biofertilizers. In terms of the field scale trials, we'll be looking at both using sites here at USQ. And so if you look at the top right-hand corner here, we have sufficient land available here at the Werribee Campus so that we have a ag plot just outside of our building, which is quite fortunate. We'll be able to then plant different crops and also assess these sites at around Brisbane and also Parklands. In these field trials, we look to compare biofertilizers with urea to assess three main areas of interest. First one is to assess the productivity over a long-term, say 4 seasons worth of crop, given the duration of the project. We'd also be looking to assess the soil resilience of the soils for which we are applying the biofertilizer, and then also to assess the heavy metal buildup in soil or the recovery in grain or biomass. As the project goes on, we would also be looking at other contaminants, namely around, say, microplastics or emerging pollutants or the persistent organic pollutants as well. So I'd just like to end on a very high level note in terms of the industry benefits and outcomes of doing this type of optimization of the biofertilizers. Because once we have understood exactly what the monetary value is, and to also make sure we have the right guidelines, this could present a potential income stream through the sales of the product and licensing of the technology, or enabling for reduced or avoided costs associated with disposal by increasing agricultural recycling. Another benefit is also to reduce farmers' reliance on mineral fertilizers, and this also could go toward not just the agricultural sector, but the peri-urban sector as well, and also parklands and the horticultural sector. As we know, we're living in times of looking at a fertilizer crisis in terms of the price of urea, and so they're obviously likely to go up even more in price. And so with the associated benefits in terms of nutrient and organic recovery, we will also realize this in terms of the actual opening up markets to biofertilizers into the future. And lastly, we could assess a monetary value in relation to the sale of the product based on the overall urea fertilizer market in Australia, which is estimated at around about $1 billion Australian dollars. And as I mentioned, the biofertilizer market is set to only increase into the future, as recent international studies have reported. So that's just a general overview of our work that we are going to conduct as part of the ARC Nutrients in a Circular Economy Hub. We are really looking forward to commencing this project with our project partners, and I've got my details there below if there are any questions to follow up. Thank you.
Okay, thank you for that recorded video from Bernadette. So we actually have completed our afternoon session. So unfortunately, Professor Liu Ye from University of Queensland is not able to come today. So she's sending her apologies for today's session. So we come down now for the floor is open for questions. Is there any questions or comments from the group with regards to the presentations from the presenters this afternoon for the second session?
Leonard, can I ask a question from Jeff?
Yes, go ahead, please.
Okay, thank you, Jeff. That was Jeff Powell. Yes, thank you for presentation. I just was wondering, have you thought or before looked at changes in the stiffness or compaction of the soil also? Like not just biochemistry of it, but how it may stiffen. Thank you.
No, we haven't measured that. Is there a reason why you're asking?
I just I mentioned, like in this hub we have this interest of using the treated urine and with some additives, bacteria and so on, to stabilize the soil so it won't settle much and land subsidence should reduce. And I just want to see, do we have some expertise we can use? And I'm a civil engineer, so I'm sure this needs very bit of biological sort of expertise.
The microbes that are being added to the soil will influence that, as will the plants that are growing in that soil as well. That's something that is fairly straightforward to measure using a soil penetrometer. So it's certainly something that we could incorporate.
We will keep in touch.
Yes. Yep.
Wonderful. Thank you. Thanks, Zed. Thanks, Jeff. Any other questions from others?
Michael and Said have raised their hands.
Sorry?
Said and Michael have raised their hands.
Okay, I can.
Okay, I could.
Yeah.
All right, yeah, go ahead. Yes, sorry. Yeah, you go ahead.
I can go ahead. My question is mainly, or a comment towards Jason and Dana's presentation and the group. I think their work is really interesting and very complementary to the work that we are thinking as part of economic evaluation, because my understanding is that they would also do a lot of stakeholder consultation and understand their perception and from different end users. And there is lots of complementarity, and I think we need to be more frequently in touch, I think, especially in these two groups. yeah, it's just a comment. Yeah, thank you.
Thank you. And do you have a comment on that, Jason, as well?
I would just say we have already been in communication with Carla, and we intend to, because the two, particularly Griffith's work and the two streams of Griffith's work is very important and is parallel to our work. I think there's some differences, which is good. There's going to be some slight differences, which is great, but I think we need to work together, and they need to be a little bit more complementary now that we know where we're going.
Absolutely. And I will try to be more on board from now on, especially with this aspect. Thank you.
That's great to know. That's great. Michael, please.
Yeah, thanks. And it's sort of a follow-on related question to Syed's question, just with towards Dana and Jason's projects. I mean, I just was thinking about your objective 3 around the perceptions, and thinking also about the work we've done in the the water sector about recycled water and how things got politicized, and I just sort of wonder with this hub, it maybe seems it all sounds fantastic to us to consider human urine for fertilizer products, but to get that message right early on, to get the market perception right early on, to me is just from the water industry side of experiences, and it also works in other areas as well. Seems like a really important study. So yeah, it was just more of a comment, but I don't know if you've got some thoughts on that already about that perception. Matter. Yeah.
Yeah, I certainly, because I think one of the aims of our projects is there's certain gaps in the current knowledge, particularly about yellow water and that sort of thing. But I think that part of our project is there's also a lot of other areas out there and a lot of other sources of knowledge in parallel, which have operated in parallel. So it's a bit of a balance, particularly similarly in circular economies. We're focusing on particular dimensions of circular economies here, but some of the other dimensions of circular economies might have those as stronger insights that can relate to this project. And I think that's the sort of point you're getting at there, is that sort of, there's many different knowledges out there. They can be very different in terms of perception, and we have to be very careful there.
Well, yeah, and it's how things can be politicized, like, the yuck factor with recycled water, and Toowoomba, a whole project was like, canned. Just because once things become great, and that's a great outcome, from this hub, would be that it goes into a bigger scale, and something just knocks it down because, somebody wants to say that there's, for example, in the water, is how do you know hospital waste is not in there or something like that, and just creates a big issue that we have to deal with, besides all of the greater benefits that we already know. So it's just things like that come to mind, just in getting that marketing right. And I think, Perth has done it well, and obviously Singapore was a fantastic example for recycled water, but yeah, it can go wrong if it's not done right in the early phases.
I agree totally. And as if we don't actually talk to all the different stakeholders involved, in particular the political, there's been many a time a minister has shot down a project, recycling project of many different types with a single statement in the media.
That's right. So. Yeah. Yep. Well, very important work. I look forward to it. Yep.
Okay, thank you. Thanks, Michael and Jason. We have Stefano, please, Stefano. And also, I just want to say that we have colleagues or team members from Bernadette's team as well. So if you could also probably answer on behalf of Bernadette, just in case.
Exactly what I'm after. Thank you, Leonard. My question is for Bernadette. So maybe Dio or other collaborator might address that or report to.
I will try.
Yeah, it's just a matter of synergy. In her video, Bernadette said that she would be ready to start in August and going through to summer. But our pilot plant in Brisbane is not going to be up and running until next year. So we'll only be able to provide the urine-derived fertilizer from the UGOL trials a little bit later. So, so how is that going to work? Or is there other urine-derived fertilizers that are available for trial? I think that because she mentioned urban utilities, there should be some synergy there, and I think the timing would be critical.
Yeah. No, thank you for that. The work that we plan to start at the end of August is mainly around work package 2, which is around the biosolids, derived fertilizers, and biochar. Because that is in the glass house, if then we have materials from your work to be tested in the glass house and the conditions will be exactly the same, then we can rerun the experiment later when we have the material from your work.
Okay.
All right, thanks, Stefano. And Eugenius, Sean, please.
Yeah, just my question goes to Jeff. So Jeff, the people trying to develop smart fertilizer to reduce the loss of the nitrogen, and our urine fertilizer, we have a lot of carbon compound, which are different from the normal commercial fertilizer. So I'm just wondering that whether you can try to develop like a smart fertilizer, because based on our own characteristics of the U-Gold and the over fertilizer, the mixture of the carbon, nitrogen, phosphorus, so many micronutrients. So whether some of the binder can be utilized, and then you can just spread this urine fertilizer in your soil condition. So let them slowly releasing, rather than just to release on the groundwater system and then quickly disappear, and then this contaminates the environment. So whether you can think about some of the smart fertilizer from our over and U-Gold fertilizer system. Do you think it is possible?
I kind of look at smart as just a marketing ploy for something that's slightly different from something that's conventional. And so looking at it from that perspective, the fact that these fertilizers contain a lot of micronutrients, but also carbon is an additional benefit. So in some of those really poor soils that we're working with, there's very little carbon in those, and the only carbon that is going into those soils is carbon associated with bacteria that might be fixing carbon from the atmosphere, or plants when we can get them to grow, plant roots that are adding carbon to that soil. However, the conventional fertilizers don't have hardly any carbon in them. That carbon that's in these urine-derived fertilizers can be a way to prime those microbes that are assimilating the nutrients, holding them within the soil until the plants grow to the point that they can then take up and assimilate those nutrients instead of them just being lost either through gas into the atmosphere or via leaching or via runoff. So I think that's a selling point associated with these fertilizers that really sets them apart from the conventional products.
All right. Thanks.
Thanks, Jeff. I'm very aware of the time, so I guess we have one more question from Bizat. It's still a very interesting discussion, but just take probably one more question. Bizat, are you raising your hand, or is that from previous one?
Yes, just a quick question. I think this question is to everyone. Please excuse my knowledge if I don't know much, but I just wonder, is there much difference between the urine that human produces and what we get from the farms, from cattle and so on? And are we focusing mainly here on the human urine, or because I know we create a lot of urine in the farms as well? Can anyone by any chance answer this question? I don't know who might be right person. Sean, yourself, maybe, I'm not sure.
Yes, we are also, we are very much open for the our nitrogen, phosphorus, our fertilizer source. So it doesn't have to be human urine source. It can be a pig or cattle, even any other industrial wastewater. So as long as we have a lot of rich nitrogen NPK water source, so we are very much interested, because basically our technology is very much similar to recover this nutrient. So you can also expand your scope if you have any good source of the pig wastewater, even cattle wastewater, any animal wastewater. They just utilized a lot of the excrete, and then we can recover their own nutrient using our technology.
I see. So the technology kind of we develop, it is kind of versatile. I guess can be used for any type of urine. I see. All right.
That's correct. That's correct.
Thank you.
Yeah. Also, yeah, if Leonard agree, just last question. So we have utilized so many different terminology of the fertilizer. Some people, like Dana mentioned about renewable fertilizer. And then the Benedict, she's talking about biofertilizer. And some people are talking about urine-derived fertilizer. And also I'm talking about the organic fertilizer or NiCE fertilizer. So we are just mixed all the term like renewable fertilizer, biofertilizer, NiCE fertilizer, organic fertilizer. My question is, which fertilizer we are producing from human urine or animal wastewater or any nutrient-rich wastewater source? How we can call this fertilizer? Do you have any good justification? Is it biofertilizer or organic fertilizer or renewable fertilizer or maybe urine-derived fertilizer?
Hang on, so that's after the quick stuff.
That could be a collective outcome of this program to define and standardize terminology around fertilizers.
That's correct. So we can utilize the consistent way of the fertilizer. So maybe that's the next our question to the next summit. So we will answer what's the best way to represent our urine-derived fertilizer or biofertilizer, renewable fertilizer. So we will discuss again. So if you have any good justification, please send the email so we can share our knowledge through email. That's what I propose.
Yeah, Sean, you could make a survey and everyone can vote or something.
That's a good idea. We can send another survey after this following up our first summit.
Call for suggestions and then a vote. Yeah.
I'd also suggest maybe there's a technical name which could be used by the people who are here, but there might be also a better name which actually the market wants.
Yeah, exactly.
To hear.
Right. Yeah,
so
I was going to say.
Yeah, I could ask my kids, for example, see what they say.
Definitely, we will remove the word urine there if we want to market, probably. For the factor. So yeah, if there's urine there, there's gonna be an issue for the lay people. Yeah. Anyway, yeah, we can have more discussion on that in the future. All right, so I guess we end up our second session. Thank you very much for all the speakers, including the speakers for the first session as well. It has been a very productive discussion, and I guess we are at the end of this summit. So I'll call on Sean for the parting words and some final message, please.
Yeah, thank you for your participation for this first NiCE summit. So I'm very happy to get together and then know each other. So all the people, so also very happy to start our project finally during our very difficult time for this pandemic. And thank you everybody for your strong support. As your CIs, also you are the person to bring the industry partner Also, thank you very much for your strong support to deliver your project. And we just know each other from this summit, so you can send the email to everybody. You know that who is doing what kind of research, what kind of knowledge they have, what kind of collaboration you can accelerate with the other collaborator. So this is the good timing. You can now feel free to contact anybody in this group, in this CI, or any PhD student, so you can have a collaboration. Also, next important item is the second AIC NiCE Summit will be held in 17th of November. So we will invite some of the important people for the launching of this AIC NiCE Hub. So if you want to propose anybody who want to talk in the launching in our project, so please let me know. Also, this is the in-person conference. Also, we can organize the summit, so you can present based on your progress of your research project. Also, we can finalize your annexes C, and then industry engagement is the most important for our project, because they will support more project, not only this existing cash contribution, but also we want to extend our scale up or some other opportunity, because you have already minimum project. So based on this project, for next couple of years, we can extend some more cash contribution from industry partners. So please let us know if you need any support. Also, you just organize a meeting with your industry partner regularly, and then you will have more trust to bring the more cash contribution in this project or some other research funding opportunity. So that's what I can propose for this first summit. Thank you again all, and then looking forward to seeing you in our second summit. So we will have an in-person conference again in November. Thank you very much.
Thank you.
Thank you very much. Thank you.
Thank you. Bye-bye.
Thank you, everyone. Take care. Bye-bye.
Bye.
Thanks. Bye.